All right, today, I'm having trouble finding the right name. All right, today we are going to be talking about special right triangles. And these are right triangles in which the sides are easy to find and you should be able to get to them, to these measurements really fast just by looking at the triangle. Our first type of special triangles we're going to talk about are Pythagorean triples. Pythagorean triples are whole numbers that solve the Pythagorean theorem. And these are ones that, guys, you just have to memorize these and just be able to recognize them. So our first set of whole numbers is 3, 4, 5. And if we use the Pythagorean theorem with this, I'm just going to show you with this one example of the Pythagorean theorem. Then 3 squared plus 4 squared should equal 5 squared. So we get 9 plus 16 is 25. And lo and behold, that works. Now, on top of this, you can multiply these Pythagorean triples by any number to get other Pythagorean triples because, again, when you think about similar triangles, that's kind of how they work. So if we multiply this Pythagorean triple by 2, we'd get a 6, 8, 10 triangle because we do 2 times each of them. Or 3 would give us a 9, 12, 15. Or 4 would give us a 12, 16, 20. So all of these are Pythagorean triples with that root of a 3, 4, 5 triangle. Okay, the next one that you need to know is a 5, 12, 13 right triangle. So those have a relationship 5, 12, 13. And if we multiplied them by 2, you'd get 10, 24, 26. You can multiply it 3, 4, 5. So I'm not going to go over all of those. The next one is a 7, 24, 25 right triangle. And if we multiplied that by 2, we'd get 14, 28, 50. And then finally, we have an 8, 15, 17 right triangle. And if we multiply that by 2, we get a 16, 30, 34. So these are all special right triangles because they all have whole numbers as their legs and hypotenuse. The next one, which is the one at the top of your sheet, is a 45, 45, and you guys need to change this right here to a 90 degree. So 45, 45, 90 right triangle. And these are special because if you guys remember, when you have the two angles the same, then your two sides are the same. So this is an isosceles right triangle. Okay. Your legs are those short sides and they are the same. So your legs we're going to represent with the variable x. Okay. So they have the same measurement, both legs. And the hypotenuse is we're going to do a little trick and we're going to take the x and we're going to multiply it by the square root of 2. And so this relationship holds true for any 45, 45, 90 triangle. So let's see it in practice. So right here, there's our 45. So this is our other 45, which makes these legs congruent. So 8 is going to be the measure of our other leg. And that is essentially our x. Then we take, to get our hypotenuse, without even doing the Pythagorean theorem, because the point of these is that you don't do the Pythagorean theorem. You're going to take your leg measure and multiply it by root 2, just like that. That's all you do. So now let's look over here at number 2. We've got 25 for one leg. So our other leg is going to be 25. And then our hypotenuse is just 25 root 2. Okay, now the last one is where it gets tricky. So this one, they gave us the hypotenuse. So if the hypotenuse is 19, how do we get back to our leg measure? Because the leg is x. Whoops. The leg is x, not the hypotenuse. So we need to set our hypotenuse equal to x root 2. So we're going to say this is going to equal x square root of 2 times the square root of 2. So I'm going to divide by square root of 2, and I get 19 over the square root of 2. Now, this would be fine, but you cannot leave square roots in the denominator. Like, that's just not right. So what we're going to do is we're going to multiply by a special form of 1. So we can make a fraction where the top and the bottom are the same. So here, square root of 2 divided by square root of 2, that's just 1 because the top and the bottom are the same. So we're multiplying the 19 times square root of 2 over times this special form of 1. When we do that, you have to think back to how you multiply fractions. So on the top, we get 19 square root of 2, and then on the bottom, we get square root of 2 times square root of 2, or square root of 2 squared, which just gives us 2. And so all of your, if they give you a whole number for your hypotenuse, then your legs are going to have that hypotenuse, square root of 2 over 2. So this is the pattern that you're going to look for. So, and then again, x and y are the same. So we get 19 root 2 over 2, and then 19 root 2 over 2. Okay, our last special right triangle is a 30, 60, 90 right triangle. Now, these are important because they have a 30-degree angle and a 60-degree angle. Notice that the shorter leg is always opposite the 30-degree angle. So this is our short leg right here. I'm going to actually color code this a little more for you. So this is our short leg that goes opposite our 30-degree angle. And opposite our 60-degree angle is this long leg over here. Okay? So our short leg is our x in this case. It's our whole number to start with. Now our long leg is going to be x times the square root of 3. And then our hypotenuse, which I'm going to do in blue, our hypotenuse is just 2 times x. So notice that starting out, these are that the short leg and the hypotenuse are kind of our whole numbers. And then that long leg has that weird square root of 3 going on. So we're going to see lots of examples with this so you can get comfortable with kind of how to divide and move things around. So number 4, they give us that 60-degree angle, right? So that means that x is going to be our long leg. That 5 over here is our short leg. So if 5 is our short leg, that's our x. So then our longer leg, oh, I should have done that in green. Sorry, our long leg over here in the green is going to be that 5. Ooh, let's try that again. 5 times the square root of 3. And then our hypotenuse, which is y, is going to be 5 times 2, or 10. Okay, on the next one, we've got that short leg again that they gave us. It's 14. So our long leg, which is y, is going to be, so here's our long leg, is going to be 4 root 3. And x, our hypotenuse, is going to be 8. 4 times 2 is 8. Okay, now let's look at the next one. For the next one, they gave us our hypotenuse. So now we kind of have to think backwards. If 2x is 32, then x is going to be 16. So that means that our short leg right here is going to be 16. And then our long leg is going to be 16 root 3. And we're going to pause this video here, and we'll pick up in our next video.